G'day guys, today we're going to try and work out whether a function is even or odd. Like for example, if f of x equals to 3x squared, does that make it even, just because the power is even? What about g of x equal to 5x cubed? The power is odd, and a lot of people will think it's odd because of that. But the power has nothing to do with whether a function is odd or even. And h of x here has both cases in it, x cubed plus x squared. Now that could mean it's neither odd nor even, but we won't know for sure until we do the calculations. There are three types. It's either even, odd, or neither, and we're going to determine which is which for each of these functions today on MathBase. So first off, you need to know what makes a function even, or odd, or neither. When a function is said to be even, it's going to have this sort of property, where when you're given a rule for f of x, you should be able to manipulate it such that f of negative x will equal to the same rule, and that would make it even. And if that doesn't work, then you want to try the odd relationship instead, and see if negative f of negative x will end up equaling back to the original rule. And if it fails these two tests, then you will just say it's neither. So in the case of f of x equal to 3x squared, f of negative x will involve replacing the x in your rule for negative x. And negative x squared means you're taking negative x and multiplying negative x again, which makes it positive x squared. That simplifies this to 3x squared, which happens to be what f of x is as well. So we can say f of negative x equals f of x. It's come full circle. And that makes this function even. Now you don't have to go any further than this, because each function is unique. It's either going to be even, odd, or neither. You're never going to get something that's even and odd. And if you do, then it won't be called a function anymore. A circle, for example, is even and odd, but a circle is not a function, so technically it doesn't count anyway. Now I would say you should still go a bit further and test the odd case anyway, just to verify that you did this correctly. So if we were to test negative f of negative x, we already know that part of that is 3x squared, and we just need to put a negative in front of that, making it negative 3x squared. And we can see that that is not identical to f of x, meaning it's not odd. So clearly this function is even. Now for this next one, g of x equal to 5x cubed, since we're using g as the function name, let's just replace all the function names on the right side with g's, just to make it a bit easier to follow along. So first up, we're going to test the even case. G of negative x equals 5 times the substituted form, which is negative x, inside the bracket. And since we're putting that to the power of 3, negative x times negative x times negative x has 3 negatives, meaning the overall result will still be negative. And so we have negative 5x cubed, which is not equal to g of x, and so it's not even. Let's test the odd case and see. Negative g of negative x, we can see that's going to have a negative outside of what we just found, making the whole thing become positive again, and so we have 5x cubed, and that is exactly what g of x is, meaning this must be an odd function. Now with this last one, h of x equal to x cubed plus x squared, we'll update the letters from g to h now. And for the even case, we can see that h of negative x is going to have negative x cubed plus x squared as its result. And that is not equal to h of x since there is a negative in front of the answer. So it's not even. So what about the odd case? Negative h of negative x will have a negative in front of the previous result, and that turns it into x cubed minus x squared, which again, h of x doesn't have negatives in it. So it's just not identical, meaning this function is neither even nor odd. And so we just say this function is neither. And that's all there is to it. It's a fairly straightforward process. You just need to test these two equations every single time to see whether it's going to be an even case, an odd case, or neither. And if you wanted to turn an even case or odd case into a neither case, it's actually pretty easy. Like x squared, for example, is even, but not because of the power. And if you added 1 to it, or 5, or minus 3, or something like that, it will immediately make it neither when you test the function. And this is not limited to just power functions. It can be tested for all sorts of functions, like 2 to the power of x, or log base 10 of x, or even the square root of x. Some of these functions are odd, some of them are even, some of them are neither. Do you have a question about whether a function you're working on is even or odd or neither? Put it in the comments down below. And please like this video if you found it helpful, click that subscribe button, and ring the bell so that you can get notified for future videos. Thanks guys, have a good one, and see you next time.